Okay, find all of the roots. Okay, it's similar to the last one we just did. Again, what do you think our first step would be? We know it's a cubic. It doesn't have any greatest common factor to take out, like an x, to make it a quadratic. So we need to find a rational zero to get started. We could do all the factors of 5 divided by the factors of 4. That would be 1 and 5, 1, 2, and 4. That would give us 6 possibilities, all plus or minus. That makes 12. Or what else could we do to find that first zero? Graph it. Put it in the calculator. You can't put it in the quadratic formula yet, right? You're going to have to graph it first. First you can invent it, okay? Okay, so I already have it in the calculator. And the graph is kind of, you could see the graph coming here. It definitely looks like it's crossing once there, but it's, let me move that in case you're trying to get that on the calculator, because I can see you are. Right. I mean, we know it's a cubic. We expect that it has a shape that looks something like that, but it's not always so exaggerated. You know, it could just be a little bend in the curve, which takes the place of one of those turning points. It looks like it's crossing around 0, but I can't see what's going on. So I'm going to zoom in, hit the zoom key, and then zoom in with a 2. You have to hit 2 and then enter, and see how the graph is crossing. Okay, it's crossing in between 0 and -1. It's a fraction. It's a fraction that's closer to 0 than it is to -1. Well, just looking at our possible rational zeros, right? If it's a fraction less than 1, it's not going to be 5 over 1 or 5 over 2 or 5 over 4. It's either going to be 1 over 2 or 1 over 4 or -1 over 2 or -1 over 4. Which one do you think it looks like? Right, look at right there. In between the 0 and the, it's definitely not a half, right? It's probably the -1/4. How do we confirm? Synthetic division, right? Let's do synthetic division with a 0 of negative remainder of 0, right? So here we go. From the calculator, well, we're just checking now. I'm not even going to say that. -1/4 is what it looks like. The coefficients are 4, 9, 22, and 5. Bring down the 4. What's that? No, the 0 is -1/4. The factor would be x plus 1/4. Get it? When you're dividing by, if I was dividing by x plus 1/4, then what would you say is the 0? -1/4. And when you're reading the zeros off of the calculator, that is the 0. It's not this number, it's the 0 actually. Okay, let's go through the multiplication. -1/4 times 1. -1. Come on. Come on. -1, add. -1/4 times 8. How about -2? Add. -1/4 times 20. -5, 0. So what does that tell us? That -1/4 is the right 0, right? So this is definitely a 0 from the calculator. All right. Now, what do these numbers represent? So what should I write? 4x squared plus 8x plus 20. So if there are 2 more zeros, they're coming out of there, right? So let's see. If I set it equal to 0 and solve, first thing I'm noticing is there's a greatest common factor. We can make these numbers a whole lot smaller. 4, right? Since you notice that, I can just divide. I'll divide everything by 4. Right? And now I got x squared plus 2x plus 5 equals 0. So we'll use that. It's not factorable. You cannot think of factors of 5 that add up to 2. So we have to use quadratic formula. X equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 5 divided by 2 times 1. X equals negative 2 plus or minus the square root of 4 minus 20 divided by 2. X equals negative 2 plus or minus the square root of negative 16 over 2. Okay, what kind of solutions we get in here? Imaginary. What is the square root of negative 16? Say again? 4i, right? So this is going to be x equals negative 2 plus or minus 4i over 2. And then because the 2 divides evenly into 2 and into 4, you're going to get negative 1 plus or minus 2i. So again, it was a cubic, so we expected 3 zeros. We found the rational zero in the calculator, negative 1/4. We confirmed it. And then we used the reduced polynomial in the quadratic formula, and we found the last 2.